Here we go with section 2.1, and this section is all going to be about reasoning and logic. So this is just an introduction to it, although it covers quite a bit of material. So be very careful as you go through this section. Make sure that you are getting your questions answered as you go so that you don't get behind. Okay, in this section, we're going to be working with logic and reasoning skills. Now, when we work with logic, we work with statements. And you'd think, okay, statements, we know what statements are, but do we really? Let's make sure that we do so that we don't accidentally, um, you know, make some logical errors. Statements are sentences. Now, they can either be verbal or written or mathematical that are either true or false, but not both. Now, that may sound really simple, but there's a huge distinction between a statement and a non statement. And statements do not have to be true. We show that they're true or that they're false. It's not up to us to worry about that. I mean, statements can be false. So I listed out some things here for you, some things that were statements and some things that are not statements. So, for instance, if I say the sky is purple, that is a statement. It happens to be a false statement, but it is a statement. If I were to say something like her eyes are brown, that is not a statement. Whose eyes? Who is she? Are you talking about me? My eyes are not brown. So, who you have to be very specific about who and what you're talking about. If there is any way that you can find an example where this doesn't make any sense, then it's not considered a statement. So it's not specific enough. For mathematically written statements, 2 plus 3 equals 5, that's a statement. That happens to be a true statement. X plus Y equals 5, though, is not a statement because there are too many cases here of things that X and Y can be. There are too many variables. So this, there's just no way that we have any way of knowing what X is or what Y is. So that could be either true or false. We don't have any idea. There's no way of showing because we don't know what X is and we don't know what Y is. Here's something that is considered a statement. That is, Obama was the 44th president. That happens to be a true statement because it is something that we can verify and we know for sure. This is not a statement. Obama was the best president. Now, while some people believe that, some people don't, that can be true and false at the same time because there are a lot of people who believe it, there are a lot of people who don't believe it. So it just depends on who you ask as to what they would say the truth or false of that statement. So this is an opinion. This is not a statement. So we're going to be talking about statements as we go through here. Now, we also have to have or be able to do what's called negate a sentence or a statement. Now, negating is exactly what you think it is. It's the negative. It is the opposite or not. So to negating a sentence means to completely change its truth value. So if it was a true statement, we make it a false statement. If it was a false statement, we make it a true statement. Um, Sometimes it's not difficult at all. Sometimes it's real easy to do, but then sometimes it gets pretty tricky because we have to make sure to completely change the truth value, and that can get a little bit hairy. So I've come up with some statements here and written them down for you. So our first statement is 2 plus 3 equals 5. Now we know that to be a true statement. So the negation of that is where we would want to make that false. So I've written 2 plus 3 does not equal 5. That would be the opposite, or make it not truthful. Okay, here's a statement that says all students like hamburgers. Now think about what that means. That means that every single student, all of them, like hamburgers. So what would make that false, or what would be the opposite of that? Would be if even one person liked did not like a hamburger, then that statement would not be true. So we negate it by saying some students do not like hamburgers. Now, you might have been tempted to say no students like hamburgers and think that was the opposite, but that's not true. That's an extreme. We're talking about negation just simply takes the statement and changes the outcome of it from being false to true or true to false. So all we have to do in order to make all students like hamburgers into a false statement would just be to show that one of them did not like hamburgers. So we say some students do not like hamburgers. Okay, if we have a statement that says some people like math, now that doesn't mean all of them. That just means some. So if there's one person that likes math, that would be a true statement. So in order to make that false, the opposite of at least one would be none. So no people like math would be the negation of that. No person likes tomatoes. So nobody, not anybody, not one single person likes tomatoes. So to make that false, we would have to find someone who did like tomatoes. So that would be the negation of that statement. Now, when we work with logic specifically, we usually use letters like P, Q, and R to stand for statements. And when we negate that, we put this little tilde here in front of the letter. So whenever you see something like this, that literally reads not P, and it would be the opposite of P. So if a statement happens to be true, then the not of that, or the opposite of that, would be not true or false. So that's what that means. So not Q, not R, those are all saying the opposite of. Now we can also put these symbols together into compound statements, which we call and or statements. There are very, very specific symbols for these. When you are talking about and, we use this up caret symbol. So anytime you see this up caret symbol, it's read as and. Now, and means both statements must be true for the compound to be true. So let me give you a for example. For example, if I tell you that when I get off work, I'm going to go to the grocery store and I'm going to go to my parents' house, then if I do, if I go to the grocery store and I also go to my parents' house, then I've told you the truth. If I go to the grocery store but I don't go to my parents' house, I didn't tell you the truth because I said and. So the only way that that statement could be true is if I follow through and I do both of those things. So for an and statement to be true, for the compound to be true, both statements must be true. Okay, we also have an or situation, and that is denoted with this little V shaped. It's like a downward pointing caret. So that means or. In an or situation, only one of them have to be true in order for the whole thing to be true. So for instance, if I said when I get off work tonight, I'm going to go to the grocery store or I'm going to go to my parents. Well, if I happen to do both of them, I didn't lie to you. If I did one of them, I didn't lie to you. The only way that I would have told you a lie or a falsehood is if I didn't do either one of them, because I said this one or that one. So or means that one of the statements must be true for the compound to be true. Now, or is also called a disjunction, and is also called a conjunction. So the things have to be the same. They have to be doing it together. So conjunction bringing together, or disjunction kind of breaking apart. So I know I'm throwing a lot of stuff at you really quickly, and I'm sorry for that, but there is a lot of information in this section. So here, didn't quite carry my table properly here. If we look at this in table format, what we do is we list out P and Q representing some statement. Like saying, when I get off work tonight, I'm going to go to the grocery store. So going to the grocery store would be P. Q would be going to my parents. So if you're talking about an and statement, I have to do both of those in order for me to be telling the truth. If I only do one of them or none of them, I told you a lie. So those are false. So whenever we're talking about a conjunction or an and situation, the only time it's true is whenever they're both true. When we're talking about a disjunction, which I hated that these didn't come out. Oh, I notice up here, I see now that they didn't. My lines didn't show up correctly, but that's okay. Okay, so here we have the same exact situation. Going to the grocery store this time, and going to my parents' house, but this time we're going to be talking about or, because that V-shaped symbol means or. So you can see that going to my parents, or I'm sorry, going to the grocery store or going to my parents, if I do both of them, that's a true statement. If I do one of them, if I go to the grocery store but not to my parents, I still told you the truth. If I don't go to the grocery store but I go to my parents, I still told you the truth because it was an or. So only one of them have to be true in order for the whole statement to be true. But if I don't do either one, then I lied to you. So that makes a false statement. Now, these can even get really fancy. So and I want to look at this because I want you to see exactly what's going on here. This is where mathematics and language and philosophy mix together, because we take logical arguments, and we can break it down and assign it to variables, and we can do truth tables with those to see whether they are valid and logical arguments or not. So that's very interesting, I think, whenever you get to thinking about it. Okay, but I should have several boxes in here. So let me do this and try and get I don't know why it's taking some of my lines off when I upload it into this Starboard program, but that's all right. We'll make do. Okay, so here we have just a statement. And in this case, it's, P's and Q's, but, it could be going to the grocery store, going to my mom's, whatever. In here, we have a statement where we're combining a lot of those things. So this says not P or Q. We do that first, and then join that and not Q. So the easiest way to do out these truth tables and logic is to make sure to begin with that you have a table for everything you're going to need. So we've already got our P's and Q's. These are the only situations that can happen, with one statement being true, the other one true or false. Then the first statement could be false and the second one could be true or false. We need to also, though, now list out what is not P. Well, not P is the opposite of P. So if P happens to be true, not P is false. If P is true, not P is false. If P is false, not P is true. And if P is false, not P is true. It's the exact opposite of P. I'm also going to be using a not Q in some of this. So let's go ahead and get a column for not Q so that we can look at that too. So again, not Q is the exact opposite of Q. So where Q is true, not Q will be false. Where Q is false, not Q will be true, and so on and so forth. Okay, now there is an order of operations to logic, and it's just like the order of operations that you guys have already used. Parentheses and exponents first, and then you work your way out. So with that understanding, these parentheses are going to be done first. So I'm going to do not P or Q. So I'm going to look at my not P column, and then I'm going to look at my Q column. And this symbol means or. So remember, in the or situation, only one of them has to be true in order for the whole thing to be true. So not P is false, Q is true. That makes true. Not P is false, Q is false. That makes false. Not P is true, Q is true. That makes true. Not P is true and Q is false. That makes true. The only situation where an or is false is if they're both false. If there's truth anywhere, then the whole thing is true. So now we have a column for that segment of my statement. Now then I'm going to add the and not Q part. So I'm going to do not P or Q and not Q. So now I'm going to be taking, let me erase that off. I don't know why my eraser's not working, but we'll make it work here. There we go. Sometimes you just have to force things to happen. So now this is an and statement. So we're going to be looking at the not P or Q column, which is here, and the not Q column, which is here. So, and since this is an and statement, they both have to be true in order for the whole thing to be true. So true and false would be false. False and true would be false. True and false would be false. True and true would be true. And that is a truth table. So that's kind of cool. Now there's another feature of truth tables that's called conditionals and biconditionals. And a conditional statement, you'll recognize this by looking for the words if and then. So such as, if it rains today, then I won't mow the grass. So again, we take those statements and we represent those with P's and Q's, but this arrow symbol is what represents the implication or the conditional statement. It's also called an implication. And you will see this in the form of this. And we read that as P implies Q. Now, a conditional statement can only be false if the first statement is true and the second statement is false. There's kind of an old story here that says, if you make straight A's, then I will buy you a new bicycle. Well, the only way that I lie to you is if you make straight A's and I don't buy you the bicycle. So truth led to false. Then I lied. The other situations that can happen are you got straight A's and I bought you the bike, so I did what I said I was going to do. Or You could have not gotten straight A's, and then it doesn't matter what I did or didn't do. You didn't come up with, fulfill your part of the bargain first, so I didn't have to then come up with my second part of the bargain. So when we're talking about conditional statements, the only time that we have false is if truth implies false. If you have T implies F. So, oops, wrong thingy there. I wanted a red pen. If you've got T implies false, then that equals false. Everything, this is for a conditional or for an implication. Every other case, it would be a true statement. Now, we can also have a biconditional statement, and that is where you're going to see the words if and only if, such as, I will mow the yard today if and only if it doesn't rain. Now, this is going both ways. So, it's not only truth implying something, but it's also going backwards, and that's why we use this symbol of a double arrow. So you'll see them written in this form of P, and then you've got your biconditional or your double implication, if and only if statement, Q. So a biconditional statement can only be true when both statements are either true or false, but not one of each. You cannot have truth implying false. That's something that you cannot deal with. Okay, now let's do something before we get to examples. I'm going to put everything together and see if we can do the implication, the nots, the ands, the ors, the conditionals, the biconditionals. Let's see if we can do it all. So we're going to be looking at this statement right here. We've got P implies Q and P joined together implying Q. And this is a logical form. So I know it kind of looks funny, but it is actually a logical form. So again, I don't have my lines that I should have, but we will improvise here. So I need P could be true, true, false, false. So I need to make these lines. Bear with me just a second here while I do this. And then Q could be true, false, true, false. These are the only four situations that can possibly happen. Okay, so now looking at this, let's break it down. Looking at order of operations, let's do the very inside first. So my very first portion is going to be P implies Q. So now, if you'll remember, this is an implication or a conditional statement. The only time that that is false is if you have T implies false. So here we've got P implies Q. So we're working with these two columns. Truth implies truth. That's true. Truth implies false. That's false. False implies truth. That's true. And false implies false. That's true. The only case we have of false is when T goes to F. Everything else is true. Now let's add to that the and P part. So I'm going to have P implies Q, Q, and then and P. We're going to do that part of it. So that we're looking at this column and P. Now, if you'll remember, with your and statements, you have to do both of them in order for it to be true. Not just one, but both. So true and true would make true. False and true would make false. True and false would make false. True and false would make false. So now then we have P implies Q and P, that's what we just did, so that's this column right in here, implies Q. So we're going to be looking at this column and this column. So we're doing an implication again. So the only time this would be false is if we have T implies F. So we have T implies T, that's true. F implies F, that's true. F implies true, that's true. F implies F, that's true. So we have truth all the way down. In this case, we call that a tautology, which means that it's a valid argument form. So in analyzing arguments by their statements, we can literally say that whatever this original statement was written out in words, it is a truthful, logical argument. That's the true meaning of logical arguments.